to cater to the other half of the audience, which is kind of your, come on now, please wait. I have an offline version too. The other side of the stage, which is graphing aficionados. So the reason why this started is initially we had a customer. Oh boy, there we go. Okay, initially we had a customer that was using Accumula in the back end. Many of our customers actually do use Accumula, and they trust Accumula for the visibility, the storage, the protection of the data. So Secure Graph was kind of grown out of that. We initially started with straight Accumula, creating our own data structures, trying to integrate those data structures into kind of like a graph-like structure. It was a big kind of like just mess of code to try to kind of keep that all together. We took from that, we moved over to Titan. Titan was kind of this interim step because we knew we had to get to like this end state where we had secure data. So we kind of went to the Titan step. The one thing that Titan was really lacking was the security piece. So whenever you create a node, hey, who can see it? When you create a property, who can see it? When you create a, an edge, who can see it? And so none of that really was supported by the Titan API. We spent probably weeks trying to kind of retrofit the API and go up and down it. We've created the Accumula. We tried to create an Accumula backend for it to, kind of store it in Accumula. But the problem is getting it from all the way up in the top of the API, all the way down to the bottom of the API, with the security intact was, in my mind, just not going to happen. And so, kind of what came out of that was Secure Graph. We had a couple features in mind that we needed, and that's where we went. About me, so I'm Joe Ferner. Again, I work for Altamira. I'm lead software developer for Lumify, and also the author of Secure Graph. I kind of went through this. Big thing here is the security aspects of it and allowing security to kind of pass through the API layers. Again, why did we choose like Neo4j and Titan? We looked at them. We knew ultimately we needed to store this in Accumula for a couple of our customers. So, again, we wrote that back end and really just didn't play out. So yeah, I kind of talked about that right quick. Okay, so what does the Secure Graph API look like? It actually looks very similar to many of other graph APIs, but with the added goodness of visibility. So for each thing that you create, say a vertex or a property, you can pass in a visibility. A visibility can be as simple as you have visibility A, or it can be a little more complex. You need both A and B. And then there's this kind of authorization piece that isn't used for kind of insertion so much, but there are kind of some custom backends that we wrote that needed the authorization, so we kind of carried that over to the Accumula as well. So with the API, one of the things that we strive for is like fast insertion rates, kind of keeping things together. And so you kind of have this like prepare vertex, where prepare vertex is basically building up an in-memory vertex representation that you can kind of be like, okay, I'll prepare a vertex. We'll call the ID v1 visibility A, and kind of set a couple properties. This property happens to be viz A and B, so that's kind of good to know. And then call save. When save gets called, it goes all the way back to the Accumula backend, and then actually gets broken out into the table structure. And I'll kind of go through the table structure a little bit later, but that's pretty much the insert happening. Kind of a short little like, okay, let's see the insert work. Great, here's some code. The same code I just saw there with the added edge, so you can actually do an add edge v1, v2, and you can put a label on edges, so v1, v2 knows the other guy. Go ahead and run that just so that we can populate some data in our graph.
So did you write the util package?
Yeah, that's actually just some boilerplate stuff to get Secure Graph up and running. This can actually come from a config file, or it can come from, Zookeeper, or, you name it, wherever your configuration lives. This just kind of sets up, like, where Accumula lives and what's it's called, demo, root, password, where it lives. There's various...
Don't write that password down.
That's right, that's right. There's a lot of, there's kind of, Secure Graph is very pluggable, kind of like Titan is, where you can basically say, okay, what do I want to use as the backend storage? Right now we have an Accumula store and we have an in-memory store. And then also, kind of like Titan as well, there's this kind of corollary, what do you use for search? Right now we have Elasticsearch, but again, it's fairly trivial to plug in different search engines. Now Elasticsearch, kind of as a side, Elasticsearch, as you know, doesn't have the same kind of security constraints as, say, an Accumula, where you can set a visibility. So for Elasticsearch, all we're really storing is we're not actually storing the data, we're just having it do I forgot the name of it, but that's okay. Yeah, the indexing is essentially of that text. Now, some people will say you can actually rebuild the text, blah, 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 but it's good enough for our customers, so it's good enough for us. But again, you can kind of swap that out with whatever technology you want. So again, when you query Elasticsearch, though, you may get extra documents back, but when it goes to ask Accumula and it says, okay, well, I got a search hit on V1. Well, V1, when it goes to look it up in Accumula, it's going to be like, I don't know what V1 is, and that's really because you don't have access to it. And so it's kind of captured in the various layers that happens. So very bit of inside, I kind of do that. All right, I'll just keep it on this view because it's easier to do. Querying, there are various querying ways. You can actually build up a Titan-style query where you can build filters together, but this is just kind of the simple, get vertex with the name V1 and the auth A. And the auth A is the important part. So when you query for this, date of birth won't be returned because it required A and B. And then when you query like this with auth A and B, you get it to return. So let's kind of see that in action, just so that I can prove that it does work. On that. So again, this is the same code that you just saw here. And so we see here, I'm just printing out name. So if you get property value name, get property value date of birth. The first time you get null. The second time you actually get no birthday. And so again, this is just using the Accumula visibility to kind of come back. Edges, again, very Titan-like, where you say direction both. So now one of the reasons that I did this kind of very mirroring of the Titan API or Blueprints API, whichever layer you live in, is because what I wanted to do is I wanted to support the Blueprints API. So what we did in Secure Graph is we actually built a layer on top of Secure Graph which implements all the Blueprints APIs. So you can use your tools like Rexter or Gremlin or various things like that to actually query against it. And one of the things that we did is, well, since you can't pass in authorization to Rexter or whatever, so when you're running your analytics, you can basically set up and say, okay, I want to run this analytic with auths A and B. And so we set up this Accumula authorization provider to kind of provide that hint. So whenever like Gremlin or Rexter or various Steampipe or whatever goes against it and it says, hey, I need a vertex, it actually looks at this authorization and uses that authorization to pass all the way through the layers. So yeah, you can use any of these wonderful tools on top of ours, which I've tried many of them, and they seem to work pretty well. So to kind of give you an idea, show you that working. Okay, so here's your Gremlin command prompt, and I can do G, B. We get two vertices back. Those are the two vertices I created, and we can do G get me V1 and map it, and you see I only get Joe Ferner, and that's because over here I said that I only have auth A. So I can go in and tweak this file and say, oh, I have A and B, and then you'll start seeing in Gremlin both A, or my date of birth as well. So And to kind of switch over here, if you want to see Rexter running, it actually has A and B, so we have two vertices, Charlie and Joe. Here they are, and you can kind of do the little view silliness. I don't even know who uses that, but yeah, that's fun. But yeah, and then here's the edge that actually appears too. So a lot of these tools that you might know and use can be worked with this. We don't use it in the back of, under the covers in Lumify for all of our UI goodness and stuff like that, because we actually need the authorizations to be dynamic and created in real time. So we actually use Secure Graph APIs directly. But if you have some analytic that needs to run, you can definitely use the Blueprints API for that. So the kind of speeding through this because I know it's getting late because somebody took too long. Sorry.
They already asked all their questions.
I know, right? I'll be easy. Yeah, that's right. Some of the other features it supports is multi-value properties, property metadata. So we actually have kind of multiple layers going on. And property metadata was really there to support your extra, like, like when you set a property, who did it, when did they do it, and then like the classification source object, we store that as well. So like if your visibility source might be like some weird XML or something like that, we store that along with it, and then we translate that XML into something Accumula can understand, like an A and a B. We also support streaming values. Streaming values, we actually store all the video and and images and all that stuff in our graph. So this is where the streaming values come in. So streaming value essentially just takes an input stream, Java input stream. You can pass it a whole image, all the binary and stuff like that, and it'll actually get serialized down into the graph data structure. And so depending on how big it is, it may overflow to HDFS. So if it's like video tends to overflow, but again, you can kind of adjust that size of where that threshold is. And if you don't want to store it, if you don't trust your HDFS, you can actually store it all in Accumula as well. But we actually store it all there. Yeah.
Do you also support security policies? Can you implement those security policies in Accumula?
No. So actually, HBase just announced being able to do both security policy, visibility, and encryption at rest. So I would not.
That's not Accumula.
What's that? That's right. That is not Accumula. You're right. But it would not surprise me if Accumula might slowly tail off now that HBase kind of supports a lot of these things. Who knows? I mean, a lot of people are attached to Accumula.
Cell-level security either.
What's that?
HBase doesn't have cell-level security.
They actually just added that. They actually have cell-level security, ACLs, and encryption at rest.
This is
per cell.
So this is like late breaking kind of stuff. This is a perfect I drink your milkshake situation, where for so long Accumula has had that one killer feature, the cell-level security that HBase hasn't been able to provide. So there's a much larger community around HBase, both in terms of users and developers who are, so HBase has really eclipsed Accumula and features and performance and that sort of thing, except it hasn't had that one killer feature, the cell-level security. And it's on the cusp of really taking over that one burning platform that Accumula is holding on to. So like Joe says, I agree. I think, so you're going to have the legacy systems are still going to be using Accumula, but over time they will kind of fade away. Because right now, like Accumula really only exists inside the Beltway. Outside of DC, HBase runs the world. So now that HBase has essentially stolen that, I mean it's open source, so taken that one key feature that Accumula had, pretty much game over, I think.
I mean, that's just conjecture, but
yeah,
that's probably where I see it. But so yeah, there's a lot of other features of Secure Graph, but again, the killer feature here again is it's kind of like what Accumula had, which is pass visibilities, pass authorizations down through the layers. And Charlie didn't really, hit on the visibility aspects of it, but every one of the properties, every one of the entities, everything that you create in Lumify, you can tag with visibility strings, so you can kind of limit who sees it, what sees it, and how it gets returned. Again, the current storage providers that we right now have Accumula and Elasticsearch. Those are the ones we happen to be using. We actually have a customer that's doing web services, so we're actually going to put a backend to Secure Graph that actually talks to web services instead. We also have an in-memory one, but that's more for your unit test and various things like that. For those of you who aren't familiar with like a distributed key value store, some distributed key value store, Accumula is very similar to HBase, but it has this additional column, which is column visibility. There's various aspects of how it stores the data in the backend, but from a user front end, this is kind of what it looks like. And each row in Accumula is made up of a unique row ID, well, sort of not unique, but a row ID, the column family, column qualifier, and column visibility, and a timestamp. So these 5 things make up a uniqueness on a value. So if you see down here, we actually have row 2 props name, row 2 props name A. This can actually exist in Accumula now, so you actually can have these 2 values, one with one value and one with another value, and that's actually, again, one of the things that Secure Graph kind of brings up is that it actually supports this as well and kind of makes it available to the user and brings it up. And the reason that we did this is say one user comes into the system and he only has like, you know, the lowest level of security. I'm like unclassified Joe user. He might only see like, oh, you know, my date of birth is, or my age is like 25. But then say somebody who might have the particular intel that's like, ooh, this is actually the most top secret thing ever. They could be like, here's his actual birthday, it's TS. From Lumify's perspective, you'll actually see both of them if you log in as TS user. You'll see one of them if you log in as the unclassified user, and you can kind of visit that data.
And
yes.
And it doesn't just have to be like security, it can be privacy things. So like, for example, the second row 2 props name with no column visibility is just Joe. So let's say a non-trusted user is maybe seeing something about Joe, and all he gets to see, because Joe's concerned about his privacy, he only gets to see Joe's first name, right? There's not much necessarily you can do with that. But for maybe a trusted user who has that column visibility associated with them, they can see Joe's full name because they're trusted or whatnot.
And we can do that with the edges as well. Go ahead.
If I run a common graph algorithm like a easy detection kind of thing, or a shortest path thing, or that kind of thing, will the algorithm be smart enough to skip over the vertices that I don't have access to?
Right, and so that's kind of the beauty of Accumula, is when you start off, say with, you start off as V1 on one side and V5 on the other. When you query for things in between, if your user doesn't have the authorization, it skips it over naturally. Yeah, like that's kind of its natural state, and it skips over it. And yeah, Secure Graph, has a couple, has a server-side iterator that makes sure that the whole vertex is eliminated, various things like that. But yeah, it absolutely gets skipped over.
So can you do negation in terms of like not?
Don't ask that.
So yes, we've talked with the Accumula people to get that working. That's TBD. So we need that for a couple of workspaces.
What's the ID for that discussion? Do you know what it's? So go on Accumula's, is it the GitHub or whatever it is, the SVN?
I don't know. It's some
there's
archaic
a public discussion going on about that where we are trying to convince them to accept that change.
And this is kind of, it's I think we're kind of abusing the not operator, but yeah, it would be nice as far as being able to exclude things. Yes. Go ahead.
A couple of minutes back, you put a label on an edge. Mm-hmm. And that got me to thinking about semantics, right? Yeah. So you've got a label that's just a piece of text. If it were instead an RDF identifier, you'd be adding semantics to it.
Right. So we actually use, so yeah, this is definitely a presentation on Secure Graph, but in Lumify we actually ingest .owl files and actually use the IRIs as the labels, and then we resolve those IRIs to just human readable things. But yeah, absolutely. So it's
you've got semantics.
Yeah, exactly.
That defines like what's a valid,
right.
What are the valid relationships of these type of?
So yeah, if you, for example, in Lumify, if the OWL file kind of described, here's what people-to-people relationships look like. It'll actually, when you drag between a person and person and say create a connection, it only shows you what the OWL file actually defines as valid relationships between those entities. Yeah, go ahead.
So just to continue with that, can you do queries in secure graph for like a parent and all its children, like given relationship type?
Yes.
Or any
Yeah.
type or something?
Yeah, absolutely. Yeah, you can start off at a vertex and you can say traverse. You can actually do find paths like that as well. So you can say I'm starting off V1, going to V5. Find me all the nose relation, or find me the shortest path using the nose relationship between those two nodes. So you can find like who knows who knows who, you know, kind of thing. So we support those kind of queries as well as traversing via that.
And just the simple thing of like you're saying, parent child, like I was showing before, right click, add all related whatever, right? You could add related children.
Right.
Just
And that's
related
under the
people
covers
generally.
doing exactly that, which
Yeah.
is it's crawling.
So if I said show me all family relations, right, as opposed to business relations.
Oh, like an
Yes.
edge-centric
Like
query.
that would work.
Yeah. Yeah, it's important. You go ahead.
Yeah, so you guys were talking about how you were bringing back both Joe and Joe Ferner, depending on your classifications on the record security. How do you guys handle that? I mean, many of you said you exposed both the higher security individual,
Yeah.
but I mean, does that mean that everything is practically a multi-value property?
Yes.
Okay.
Correct. Yeah, under the covers, everything's multi-valued.
Okay.
When you go to enter a single valued, it actually puts in a special token that's like user entered. So when a user enters it, it's user entered, and then as the various, you saw those things at the top, open NLP, et cetera, when it goes and operates on a various node and it says, oh, I'm going to add this property, which is the date of birth, it'll tag the property it creates with the key of OpenNLP or various things like that. We have URLs set up, basically URIs set up for each of the processes, and it'll tag each of the properties so you know where it came from. And then if you need to back out, like, oh, I want to get rid of all the OpenNLP thing, you can actually search across Secure Graph and say, ditch anything with the key OpenNLP.
Well, and there's a natural follow-up question to your question, which is, what happens when you have different properties at different levels that
Right.
conflict, or different values, right? And the answer to that question is it depends on what the customer, that's installation specific, how they want to handle that. Different organizations will have different workflows or properties or processes for handling that. They might want to have something where, maybe if you add something that's a higher classification level, it negates everything else, right? Just deletes everything else if they're not in tune, right? Or, if I have something that this is classified, someone else comes along and adds an unclassified property and it's the same, well, maybe that's essentially a declassification process, but that's unique to each customer will have a different way of handling that.
So, yeah. Go ahead.
So you mentioned that various algorithms like functionality or whatever, that you'll skip over what you shouldn't see. Is that determination done during reversal, or is that part of the indexing to make it faster? Because I could then benefit from a faster search if I have less access.
Right. Yeah. Right now it's over traversal, and so the traversal will actually throw it out on the node itself. So the way Accumula works is it'll cluster the various vertexes. So say you had 5 nodes, vertices 1 through 10. Vertices starting with A through whatever C will show up on node 1, and so on and so forth. And then when I go and query and I say, oh, I need vertex A, D, E, and F, it'll actually go to each of those nodes, and the node itself will actually filter down based on the visibility, and then it won't actually even leave that node if the visibility isn't met. So it's pretty quick because it's actually on the node. And so if you do something that you're like, your authorization is nothing and you get very little back, all those nodes are going to be like, nope, I got nothing. So it won't even actually plumb up the network with that kind of information. Yes.
Why can I get my hands on this?
What's that?
When can I play with Secure Graph?
Lumify.io.
Actually, yes. All right.
Well, Secure Graph.
I'm
sorry.
It's also on GitHub, and I'll show you the URL in just a second. So kind of, I'll go through this pretty quick. Secure Graph table structure. Again, you guys are the super experts on graph databases, so please forgive me if I've committed any sins in what I'm about to show you. So essentially, this is the table structure that we have for Accumula. The row ID essentially is a V followed by a vertex ID. We have a column family that's kind of like a marker, and this is kind of basically whether or not the whole vertex itself, the visibility on the whole vertex. So we'll actually say, you know, column family is V, we want to fill out these two values, and then we'll assign the visibility to this node. And this is where that server-side iterator comes in. If it doesn't, if it sees, say, like an unclassified property, but the vertex itself is like secret, it's going to actually skip over that whole vertex, won't even leave that Accumula node, and so it keeps the performance relatively high. Also on each vertex, we also keep track of all the edge IDs going in and out of it, also all the vertex IDs going in and out of it, and this allows us to do kind of like jumps a lot faster to do find paths. So instead of having to do a find path where I'm like, okay, start off at V1, go through all of its edges, grab all of its edges vertices, then grab all of its vertices, et cetera, we can kind of skip over the edge and say, no, we don't care. We're just looking for all edges that have a nose label, so give me all the V's that match that. So we can kind of skip over a lot of the edge kind of cruft that doesn't need to be brought back. And I actually did some performance, you know, tuning to make sure that find path up to like, you know, 2 or 3 actually takes advantage of that as much as possible to do some set operations. On each thing, we also store the property data and the property metadata. Property data is stored in property name key. For streaming values, this property data is actually just a pointer to where the data actually exists, and we did this for various how it does row splits and how we scale out. That way, like if we had a big video, it wouldn't end up hogging one node because it's like, oh, well, that's a really big row, so we'll store that on one node and all the rest of it. So it's a performance optimization to kind of spread out what's called tablet servers. And property metadata. Edges, yeah.
Can you comment again, what is out vertex and in vertex?
So out vertex, so like an out vertex would be like Joe knows Obama, but Obama doesn't know me. So I would have an out vertex to knows Obama, but he would not have like a out vertex back to me.
So given a vertex,
yeah,
another vertex, which is an out vertex, is one that's connected to the first one via an outwardly pointing edge.
Right. Correct. Yeah. So the edges have directionality. Correct. Yeah.
And that's for optimizing search as opposed to storage size.
You're skipping the edge at that point, right? I mean, you're just saying, I don't care about what the edge is, I'm just trying to get to the next version.
Yes.
Yeah, that's
Well, the edge is there, right? The edge is
No,
there.
yeah, well,
We're storing here for.
But you're not, what you're saying is in your search, you don't care what that edge is.
Right. We can skip
for
over
that
that.
optimization.
Yeah, exactly.
Right.
Does that mean the edges don't live as their own
Yep.
primary object?
So
They're not
right, so
standalone,
we have a separate table, which is the edge table, which is very similar to the vertex table, but you know we have this edge and we have the V out and the V in at the edge, which actually there's only singular ones of these, and then prop and proppinated data. And again, we split off into a separate table to split out the load across the tablet servers. This is purely an Accumula optimization, and it helps spread everything across, because otherwise we would end up with all the E's. So all the E's would be on like servers 1 through 2, and then all the V's would end up being on 3 and 4. You know, and so when you query, it'd be like, well, I'm just going to ask 3 and 4 because all the V's are over here. So by splitting them off into separate tables, it ends up spreading across all 5 servers, no matter what you're doing. And then the final thing that we have is this data table format. And again, this is performance optimization to create multiple tablet servers. And this is just where you can store like images, video, etc. And I think we have it currently at like a 10 meg limit. So each value would have 10 megs. And if it spills over past the 10 megs, then it starts writing into HDFS. So bigger big data ends up on HDFS. That's just how it works. And that's where we get that 10 meg limit. Elasticsearch, again, we just index it, we don't store it. We explicitly turn that off, again, for security solutions.
We actually are really close to having a working solution to actually handle visibility within Elasticsearch using child documents. So we actually have it working in the lab. It works. It's a little slower, but it actually provides that extra level of security. So if you queried with A and you're looking for a property that's AB, you wouldn't even see that document come back to Elasticsearch. So you could actually skip past a lot of that stuff that you would have to then look up and skip in Accumula possibly. So we almost have that working, which is great.
This isn't a child document.
Yeah. So
what came to my mind was, I go to Freedom of Information Act, I get back a page, and stuff is blacked out. To me, the blacked out stuff would be a child document.
Exactly.
So I get to see.
Yep, exactly.
Blacked out.
Right, exactly. And Lucene kind of supports this under the covers natively, and so does Elasticsearch. And that's exactly what we're doing. We're doing visibility filters on the child document, and Lucene actually supports, I think they're called filters, deal with two main technologies. And the filter can actually do it on the server side again, just like Accumula. So before it even leaves the Elasticsearch node, it's like, hey, can I actually leave the Elasticsearch node? Does he have the authorization? And so we have that working. Go.
Do you log that denial for that particular vertex?
Yes.
Pass on to somebody else, saying, hey, maybe they do need that information, but we need to ask.
Well, no, we don't. No, we don't go that far. But yes, we do log that. Yes, we skipped over this, and but you're right. I mean, that's definitely a pluggable possibility that we could add kind of a shim and being able to do that.
Well, and one of the things we've talked about doing is, again, if a customer wanted this, is let's say I don't have many clearances, and I look at Joe's thing, and all I see is his first name, and I don't get anything else. The system knows that there's other data there, and maybe we want to expose the user, say, hey, there is more information here that you don't have access to. Here's the person that your boss needs to contact to get you access to that.
But that's
If
a
a customer
whole
wants
new-
that.
yeah.
Some
Well, yeah, I
customers
mean,
want
sometimes
to
you
be
don't.
That's a whole new
completely
bag of That's a whole
Sometimes you
new-
don't want that too.
Yeah.
Sometimes you don't, right.
It's a whole new can of worms. But yeah, go ahead.
You ever have any weird situations where vertex A is, let's say there's secret and TS. Vertex A, secret. Vertex B, secret. The fact that they have an edge between them is TS.
Yeah.
Or the fact that they're within n degrees of each other is TS.
Yeah. We've actually ran into those situations, and we handle those beautifully. They again, like if you start off in V1, V2, it actually skips right over it. So if you come back to here, so for example, that edge that you were talking about, this edge we would tag with the same exact visibility as this V out. So it would actually have that same visibility, and it ends up getting skipped over just like any other piece of data. And so it would go to query and say, hey, do you have any edges? And it'd be like, nope, I got nothing.
Not for you.
Right, not for you, exactly. None for you. That's right, no soup for you. And again, Accumula handles that wonderfully. Did that.
So,
Yep. Oh, go ahead.
that saying, I mean, is it contextual in some ways? For example, it depends on who am I and the role I'm playing, and then could it be made visible based on the role I'm in?
Yeah, it could work on role-based. I mean, we have a pluggable authorization piece, so however you want to plug that in, when you log into the system, it looks you up in the database and it says, hey, what authorizations do you have? Oh, you have ABC? Great. Query with ABC. Yeah?
How do you handle escalation of classification level due to aggregation of data?
We don't. That's right. Yeah, go ahead.
When you say like data, we have this, data is next not stored in Elasticsearch. So what is stored in Elasticsearch?
So it's completely escaping me. It's the.
Sorry, slide.
Yes, that's right. It's why is it escaping me? Essentially, it's the reverse index of it. So it basically will say, it'll say Joe appears in document 200, but it may not say, like, if I query for 200, here's all the words that appear in it. It just does the opposite of it. It'll say Joe appears in 200. So when I query for Joe, it's going to come back and say, oh, he appears in vertex 200. So And again, some people will argue that you can actually rebuild that index. So if you go through all the data in Elasticsearch, you could be like, okay, what are all the words that appear in document 200? Okay, well, now I just sort of have the document. It's not in the right order, but I have the document, right? But again, that's, yeah, it's the best you can kind of do. Oh, yes. So on github.com/Altamira Corp, we have Secure Graph and this presentation. So all the code, all the kind of the slides, whatnot, I put that out there. So if you need that, then there you go. I think that's it. Thank you very much for.
Does that also apply to Charlie's part?
We can put that. Yeah, go ahead.
You have to set up Accumula to run this, or can you run it on some sort of?
You do have to set up Accumula. You can actually run it with the InMemory database if you'd like. So that's pretty easy to set up. So you could do it in memory, and then whenever your Java process closes, it'll go away. But you can play with it that way.
With these nice new features of HBase, you're going to convert it over to HBase?
So there's no.
No, that's a question.
Yep. Oh, that's right. So conversion, no, but we will support an optional backend, which is HBase. Yeah. That's already in the works.
Thank you.
Yep. Go ahead.
The speculative entities that you get from the entity extraction pipeline, how do you represent those in Secure Graph?
We don't. Yeah. We actually store those in just a standard Accumula table. That's the artifact ID and then there's the values. Because what we ended up seeing is that OpenNLP created so many vertices that we ended up with just data explosion, and we ended up finding, like, you do like a fine path and you kind of get wonky, and so we kind of punted for them. But we could store it in Secure Graphics. Yeah, go ahead. Yeah.
Well, you can submit.
How do you change like the model slider?
Excuse me, sir. Yeah, I like the presentation.
Right. So, yeah, in the config file here. So this is actually just a config file that lives right next to where Gremlin goes, and then this is where you configure, where your backend is, the target you're hitting, and then the authorization. So it's just a config file. You could make it load, like when you start up your Gremlin engine, you could load that config file from memory or however you chose to do it. And then same thing with Rexter, when you can find your Rexter and start up.